Partial discharge theory presented by Mr. Paul Goodbody. So, for an introduction, what is partial discharge or PD? Well, it is generally accepted as the predominant cause of long-term degradation and eventual failures of electrical installation. So as a result, its measurement is a standard as part of the factory testing of most types of high voltage equipment, and in addition, partial discharge activity is often monitored on an in-service equipment to warn against pending installation failures. So what is PD? Well, PD is an electrical discharge that does not completely bridge the space between the two conducting electrodes. So the discharge may be in a gas-filled void, or in a solid insulating material, in a gas bubble in a liquid insulator, or around an electrode in a gas, known as surface tracking or corona. So where can PD occur? Well, PD occurs anywhere there is a junction or a man-made termination. So, as stated, the termination is always a weak spot. Spouts and busbar connections. So, as stated, 85% of switchgear related failures are suspected to be related to partial discharge. So where can partial discharge occur? Well, it can occur in voids within solid insulation. It can also occur across the surface of insulated materials, and finally within the gas bubbles in liquid insulation, for example an oil-filled transformer. Where does PD happen? Well, PD can occur either phase to phase or phase to earth. In fact, anywhere we can find an electrically stressed insulation due to a defect. And what we're listening for is what we call in the trade corona. So when an insulator is subject to an alternating voltage, charge builds up within the void and the applied voltage increases or decreases. So this causes a series of discharges with charge first moving in one direction and then the other. So this results in PD having a distinctive pattern, as you can see. When viewed in the power cycles, this is what we call a PR-PD. Here are some more examples of corona on variant different voltages of cabinets. So what are the effects of PD? Well, the individual discharges are low energy, but they are very localized and can be very repetitive. So damage is caused by A, mechanical, that is via ionic bombardment. Then we have thermal, so local heating at a discharge site. And then we have chemical, and we have discharge energy breaks down chemical bonds. So as you can see, corona or PD is very, very, very destructive. So PD is classified into three. Number one is corona, number two is surface tracking, and number three is arcing. So first, corona is the ionization of fluid air surrounding conductors and is usually visible. And when we say visible, it is normally given off via white powder. But unfortunately, infrared cannot pick up corona. Now you will be able to pick up corona very faintly with ultrasound, but it is really down on the sort of the lower spectrum. So corona, really you do need a partial discharge machine to find it. Surface tracking now is the electrical tracking over contaminated insulators. Now with surface tracking you can actually physically see it. Secondly, you can hear it through EPD, through ultrasound, and also you will be able to start picking up the small heats via IR. And thirdly, arcing. Arcing has a distinctive sound, but can be picked up via PD, definitely be picked up by ultrasound, and definitely can be picked up by infrared. So the physical signs of PD. Odour, which is smell of ozone. There will be a smell of burning wire. There will be a metallic smell. Also, there will be discoloured trails or lines. And then there will also be the carbon tracks. So here we have the next few slides of examples of surface tracking. So as you can see on this buzz bar joints, not only have you got the white powder, you have also got the tracking. So you can see how it looks like a tree, or leaves as we call it, and it's tracing. So that's the carbon, and that's actually the partial discharge now starting to eat away at the metal. Another example of tracking here. As you can see, this is a bit more severe, but as you can still see around the buzz bars, there is the white residue, and that's the first part of the corona. What's happened is this has been left to go on a little bit, and that's why the tracking has now got worse. Here we go, it's another example of surface tracking. You can see now it's starting to get a bit darker, whereas the white residue powder now has started to oxidize, so it's now gone a different color, as you can see. So a quick question for you all. What type of discharge is this? Well, I've left a little gap, but obviously as you can see, we've started off with a corona. Why do we know it's the corona? Because as you can see, we have the white powder. But then it's now also gone on to something else, and that's correct, that's tracking. You can see the little carbon residue as well. So in this slide, there is some more evidence of effects of PD. So as you've seen, we have what we call the electrical tree, we have what we call the surface tracking, and then we have the carbonization. So what are the consequences of partial discharge? Well, ultimately there will be, and if it's unchecked, switchgear failure. Oh, now we all know the consequence of this, so that is we have serious safety implications. There will be collateral damage, there will be major disruption, and to rectify it all will come very expensive. So if you do have PD on your switchgear and you don't check it, this is what can happen, and we are talking catastrophic failure, very expensive to rectify. Really, it's a rule of thumb that it is essential to test before switching. So if PD is present, manual switching must not take place. What you need to do then is consult with your company policy or procedures to see whether remote switching should take place. So a quick lesson recap on this small presentation. Hopefully we have learned is what is switchguard partial discharge? Where can partial discharge occur? Well, as discussed, it can occur at joints, in bubbles and in voids. We've discussed what types of switchgear partial discharge there is. We've shown you images of switchguard partial discharge. Hopefully we've discussed the effects of partial discharge over time, where it goes from corona through to tracking through to arcing. We've shown you the examples of failure and again the consequences and the risks if you do not carry out partial discharge. So partial discharge is one of our predictive maintenance tools. So we have partial discharge, we have ultrasound, and we have infrared as well as vibration. But I'd like to say I hope that this presentation has shown you what can happen if partial discharge is not checked. If there can be any more information, please go to our website www.aris.com. Many thanks and thank you for listening.